Bismillahirrahmanirrahim. Dear students, this is the Pakistan International School Taif, and we're talking about the grade 11 and chapter number 3, and this is lecture number 28, and we are talking about the structure of molecular orbital theory. So, in the previous lecture, we done the molecular orbital theory for other elements, and there's one thing I want to tell you. There is relative energies of molecular orbitals. Relative energies of molecular orbitals. So, for the nitrogen molecule, pi to p y z and pi to p y, you have to fill first. Then you have to fill the 2px. So I will write when we draw this structure. So nitrogen atom has atomic number 7, and electron configuration is 1s2, K shell is complete. 2s2, this s is also complete, and 2px1, 2py1 and 2pz1. You can draw 1s2 from here, 2s2 also here, but it's not necessary. You can write only the unpaired electrons which are present in x, y and z. So only I write unpaired electron for nitrogen, 2px, 2py and 2pz for the one nitrogen atomic orbital. And same 2p orbitals, 3 for nitrogen like this one, atomic orbitals. So 3 electrons in px, py, pz, they are all in the same spin for the one nitrogen, and there are other for the second nitrogen. So 6 electrons. So you are going to distribute 6 electrons in the nitrogen molecule. So in the nitrogen molecule, you are seeing that according to the rule I told you, and you learn for the nitrogen, so you have to fill first two pi 2p y and pi 2p z2. According to the relative energies, when you see back, who paid this back, for the nitrogen, 2py and 2pz have less energy than 2px. This is important. 2px is raised due to the small difference of energy in the 2s, sigma 2s and sigma star 2s. That's not a pure s character, and the sigma 2px and sigma star 2px, there is a no pure p character, but they have an s and p character because between the 2s and 2 sigma 2s and sigma star 2s, there is not very high difference of these energy between s and p. That's why the pi 2py and pi 2pz, they have their original position, but sigma 2px is going to be raised higher energy. Sigma 2px has a higher energy. So these are the bonding molecular orbitals. Bonding molecular orbitals. 1, 2, 3 in one nitrogen, 1, 2, 3 in another nitrogen, 2 in the 2pz, 2 in the 2py. They have the same energy. They are degenerated orbitals, and this is the sigma 2px, sigma 2px, and there are 2 electrons are also there. So 6 complete. Now in the Antibonding molecular orbital pi star 2py pi star 2pz. Empty, no electrons, because 6 complete, 2 to 4 to 6. Pi star 2py and pi star 2pz, no electron, and also there is no electron in the sigma star 2px. This is the anti-bonding molecular orbital. This is the anti-bonding molecular orbital. Dear students, this energy increases from bottom to top. This is nitrogen according to molecular orbital theory. Px, Py, Pz for nitrogen 3, Px, Py and Z atom orbital for other nitrogen 3 electrons. First we have to fill lower energy. So as per rules which we done in the range of energies for nitrogen, first electron you have to fill the pi 2 py2, then electron between the pi 2 p z2, and then sigma 2 p x. So all 6 electrons are in bonding molecular orbitals. Then we have to draw the anti-bonding. Pi star 2 py and pi star 2 pz are anti-1, no electrons, and sigma star 2 px is the highest energy as also it is anti-1. So anti-bonding molecular orbital is going to be here, and bonding molecular orbital this is. So this is the structure here. Now if you write the electronic configuration, 2 nitrogen atoms to form a nitrogen molecule. So 1s2, 2s2 and 2p3. This is the general electronic configuration of the nitrogen. Now in the previous diagrams I told you, if there is a 1s2 k shell is complete. That's why there are 2 nitrogens, so I told you write k and k. This is a k and k. K. Then this energy is going to be increased, and then sigma 2s2, then sigma star 2s2, like this one. 2 electrons from the sigma 1s2 and 2 electrons for the sigma star 1s2. 2 electrons for the sigma 2s2 and 2 electrons for the sigma star 2s2. Then you have pi 2p y pi 2py2 is equal pi 2p z2, and then sigma 2p x2, like this one. So 2 plus 2 plus 2, 6 electrons. 2 plus 2 plus 2, 6 electrons will be. These are empty. Pi star 2py and pi star 2pz both are empty, so no need for writing this. They are empty, anti-bonding, no electron is here. So bond order in the bonding molecular orbital 6 electrons, Anti-bonding 0 divided by 2. So 6 minus 0, 6. So this will be 3. It means that between nitrogen and nitrogen there is a triple covalent bond already we done. When there is a triple covalent bond, in between there is a sigma bond which must, and there are 2 pi bonds. 1 sigma bond and 2 pi bonds are there. So the energy is required 946 because 3 bonds. So energy 946 kilojoules per mole is required to break these 3 bonds. Very strong bond is here, and because of no unpaired electrons here, all are paired, these are the empty. This is diamagnetic. This is a diamagnetic. Nitrogen molecule is a diamagnetic, and distance which is called a bond angle. Bond angle is a very short. Bond angle is very short, 1.09 angstrom. This is a very short length. Distance very short because of 3 bonds. One is a sigma bond and 2 are pi bonds, strong bonds. There are 3 bonds are here. So very strong bond, the amount of energy is going to be required 946 kilojoules per mole. That's why it has a distance 1.09 angstrom. Stronger the bond, but more multiple bonds, energy will be more, and the shorter will be the bond length. Bond length will be shorter, and it is diamagnetic because of there are 2 all pi 4 electrons and px 2 electrons, no electrons present in the bonding. So students, this is the structure of nitrogen molecule according to molecular orbital theory. Again I am telling you, electronic configuration is a 1s2, 2s2, 2p3. So 1s2 is complete K shell, 2s2 is also complete. P has 1 and 2 and 3 electrons. In degenerated 3 electrons for other nitrogen. So first they form bonding pi 2py and pi 2pz. Then they form 2px according to rule I told you many times. Then anti pi star 2py and anti pi star 2pz and anti sigma 2px because 6 electrons and 6 electrons are already occupied the bonding molecular orbitals. So electronic configuration again I am telling you. This K is for 1s2, there are 2. Then this K is for the sigma star 1s2. Then 2s2, 2 means sigma 2s2 and sigma star 2s2, 4 electrons multiplied by 2. Then pi 2py, both equal, same energy, and pi 2p, z, same energy, and then sigma 2px2, there are 2 electrons. So total 6 electrons are here. Bond order 6 minus 0 divided by 2 you will get 3. Triple bond is here, 1 sigma bond and 2 pi bonds, 496 kilojoules per mole amount. And bond length is 1.09, very short, very strong bond. And there are no unpaired electrons, so that's why it is diamagnetic. So dear students, this is about the nitrogen. Now we are going to start about oxygen. Oxygen molecule O2. Electronic configuration configuration of oxygen, two oxygen atoms to form oxygen molecule. So 2, this will be a 1s2, 2s2. Atomic number of oxygen is 8. So 1s2, 2s2 and 2p4. So there are 4 electrons present in the T. Px, Py, Pz total 4 electrons. So if you see the relative energies, I'm telling you now. If you see back 2 pages or 1 page, relative energies of molecular orbitals, A, point A. Oxygen and fluorine and their positive and negative ions, inverse of nitrogen, means 2px has a lower energy than pi 2py and pi 2pz. 2px has a lower energy than the pi 2py and pi 2pz. So if you see the structure of the oxygen, 2s is also written here. The structure of 2s is written, but you don't write. See, in the nitrogen there is no 2s. Already I mentioned, already I told you, if you write, okay. But if you don't write, there's no need for this one, as you see in the nitrogen. So if you write all, it's okay. So here the 2s written, but I'm not going to write this. Only I write only for the oxygen P. So look here. This is the energy. These are the energy diagrams. Energy diagrams for the oxygen. So this is oxygen. Atomic number 8 and P electrons 1 and 1. So this is 2p, like this. 4. There are 4 electrons in the P. 1p is a filled and 2 are not filled. Atomic orbital of the oxygen, there are 3p. Same case, also 1 electron, second electron, and there are 2. P, oxygen, 8. Atomic orbital. So when the 2 atomic orbitals mix together to form a 2 molecular orbitals, one is called bonding molecular orbital and other is called anti-bonding molecular orbital. So first they form bonding. So I told you for the oxygen, so you have to first fill 2px. X, lower energy. 2 sigma 2px bonding molecular orbital. Sigma 2px has the lowest energy. Then we have to fill with a pi. This is the pi 2py and this is the pi 2pz. This is like this. Sigma 2px has lower energy than the pi 2py, pi 2pz in the case of oxygen. Okay, then anti-bonding. 8 electrons, 4 are here, 4 are here. 2, 4, 6, 2 remain. So they must enter. This is this one is called pi star 2py and this is called pi star 2pz. So dear students, According to Hund's rule, when you are going to fill two electrons only, so there must be in the same spin. Like this. Like this. So one electron upward spin the pi to be y and one electron upward spin the pi star to be z. Don't put two electrons in only pi star to be y. According to Hund's rule, if you have more than one electron available and you want to fill the degenerated orbitals, then one you have to fill each according to Hund's rule. So this is Hund's rule, one electron here and one electron here. 2, 4, 6 and 2, 8 complete. So there is a this is called anti-bonding molecular orbital sigma star to Bx. This is so, dear students, this molecular orbital theory is superior to both Vesper theory and Valence-Bond theory. The reason because it gives bond order. It also explains the paramagnetic nature of oxygen. Oxygen is a paramagnetic molecule. If it is in the liquid form and if there is a magnetic field, it attacks towards magnetic field. Due to these unpaired electrons, unpaired with the same spin electrons present, pi star to y and pi star to z, oxygen is paramagnetic. This is a paramagnetic molecule. It attacks towards magnetic field. So, electronic configuration K sigma equals to these are unpaired. Due to these unpaired electrons, oxygen shows a paramagnetic nature. Energy 498. kilograms per mole. Bond order 2, 4, 6 minus 2. one sigma bond and one pi bond. Two bonds. Bond order is 2. So bond order is 2. Only 2 bonds are there. So its conclusion is 2 atoms, 1s2, 2s2, 2p4, 4 electrons, sigma p2, lower energy, pi 2p by 2, pi 2z2, 6 electrons, 2 electrons in pi star 2p and pi star 2pz show paramagnetic property, and sigma star 2px empty. 1s2 K-shell finish complete. Sigma 2s2, sigma star 2s2, sigma 2px, pi 2p by 2, pi 2pz2, these, pi star 2p by 1, pi star 2pz1, these, and this is empty. Energy 498 kilojoules per mole. And bond order is 2, so double covalent bond is there. So oxygen has 2 unpaired electrons in antibonding, pi star 2p1 and pi star 2pz, and it is paramagnetic in nature. It attacks towards magnetic field, very stable molecule, 498 kilojoules per mole, and the angular bond energy is 1.21. Bond length, and nitrogen was 1.09, 946 triple covalent bond, 498 double covalent bond. So students, we completed the structures of nitrogen and oxygen, go through very well. So only one or two remain behind. I will explain in the next lecture. So thank you very much.